Hey everybody. Today we're getting started on improper integration, doing integrals over infinite intervals. Here's an example of the sort of thing I'm talking about. Find the area under the graph of y equals 1 over x squared to the right of x equals 1. A picture makes the difficulty clear. This region goes on and on forever as we go to the right. It's not immediately obvious whether this area could even be finite. On the other hand, the region's getting thinner and thinner as we go further to the right, so it's also conceivable that it could possibly be finite. We're going to have to do some work to figure out whether it's finite or not. A little bit of terminology. When we have an integral where at least one of the limits of integration is infinity or negative infinity, we call that an improper integral of type 1. So what we have here, integral from 1 to infinity, 1 over x squared dx, is a good example of that. We are going to deal with it by, instead of integrating from 1 to infinity, we're going to integrate from 1 to L, where L is just some finite number. And then ultimately we're going to take a limit and let L get bigger and bigger and then go to infinity. So really a two-step process. First make it a proper integral and then take a limit. If that limit exists, then we'll call that limit the value of the integral, and we'll say that the integral converges to that value. If the limit doesn't exist, then we'll say that the improper integral diverges, it doesn't have a value. So let's actually do it for the problem at hand. Integral from 1 to infinity, 1 over x squared dx. We'll write with a limit, so limit as L goes to infinity, integral from 1 to L of that same integrand. Now that integral is one that I can handle just by doing, for example, second fundamental theorem of calculus. Get an antiderivative, plug in the limits of integration, and now I'm at a place where I just have a regular old limit. I let L go to infinity, the 1 over L goes to 0, and so the value of that integral is just 1. What this means in terms of the graph is that shaded area, even though it goes on forever and ever and ever to the right, the total area is just 1. Let's do another example. Integral from 1 to infinity, ln x over x squared dx. We'd like to know, does this integral converge? And if so, what's the value? So here we have a slightly harder integral. We have to think about how we're going to do it. First of all, let's get the infinity out, replace it with a limit, L goes to infinity, integral from 1 to L, and then use an integration by parts. This is a good candidate for integration by parts because we have a natural log in there. And so whenever we see a natural log, we always know that integration by parts with u equals that natural log is a good possibility. U equal natural log of x, dv equals what's left, 1 over x squared dx. Differentiate the u, 1 over x dx. Integrate the dv, negative 1 over x. And then apply the formula integral u dv equals uv minus integral v du. Here we have a definite integral, so after we do our integration by parts to get an antiderivative, we'll plug in those limits of integration, and then we'll take a limit as that upper limit of integration, L, goes to infinity. So even after applying integration by parts, I still have one more integral to do, x to the negative second. Antiderivative of that is negative x to the negative first. Plug in the limits of integration, and do a tiny bit of simplification. Now we're ready to take the limit. Of course, as L goes to infinity here, both the numerator and denominator are going to be going to infinity. Natural log of L, as L gets really big, is really big. So we're going to have to actually do some work to figure out this limit too. In particular, we've got to do L'Hopital's rule. The top and bottom are both going to infinity. It's an infinity over infinity form. So we take the derivative of the top, 1 over L, derivative of the bottom, 1, limit as L goes to infinity stays the same. Now this is simple. We plug in as L goes to infinity, and we just get 0. Putting everything together, the integral from 1 to infinity, ln x over x squared dx, is 1 minus the limit as L goes to infinity, ln L plus 1 over L, which is all just equal to 1, because that limit's equal to 0.